Question 4. Let sin x equals s. Show the equation 4 cos 2x plus 3 sin x cosec cubed x plus 6 equals 0 can be expressed as 8s to the power 4 minus 10s squared plus 3 equals 0. Sometimes we do have problems when we're using the IB question bank, and there's a mistake. There should be a minus 3 sin x cosec cubed x. Okay, so the first thing we do is we find our identities, and we can see that cos 2x, once again we have various options, but the one that would seem to help us in this situation is the one that involves just sine squared x. So 1 minus 2 sine squared x. So we can write that out. 4 times 1 minus 2 sine squared x minus 3 sine x. And then cosec x is 1 over sine x, so 1 over sine x cubed, 1 over sine cubed x plus 6 equals 0. Expanding the brackets, we get 4 minus 8 sine squared x minus 3 over sine squared x plus 6 equals 0. And then multiplying everything through by sine squared x, we can see that's equal to minus 8 sine to the power 4x plus 10, it's 4 plus 6 times sine squared x, 10 sine squared x minus 3 equals 0. And then we can substitute in sine x equals s, so that's 8. So we can also multiply by minus 1, so 8 sine to the power 4 x minus 10 sine squared x plus 3 equals 0. S equals sine x, so 8s to the power 4 minus 10s squared plus 3 equals 0 as required. Hence, that means we've got to use the answer to part A. Hence, solve the equation for x in the interval 0 and 0 to pi inclusive. So, first thing we do to solve this equation, use the MAM method. If you know, 8 times 3 is 24. So that tells us that if we have two values, P and Q, P times Q is 24, P plus Q is equal to minus 10. So therefore P would be minus 6 and Q would be minus 4, so we can split up our minus 10s squared into minus 4s squared and minus 6s squared. So 8s to the power 4 minus 4s squared minus 6x squared s squared plus 3 equals 0. And now that enables us to factorise these first two terms, 4s squared, 2s squared minus 1. Take away 3 times 2s squared minus 1 equals 0. So that leaves us with 4. These two parts here can become the first bracket. So 4s squared minus 3 times 2s squared minus 1 equals 0. That is IGCSE work, so you need to, if you're not sure about how to factorise all that, then you need to practice. So 4s squared minus 3 equals 0, so s squared is equal to 3/4, or 2s squared minus 1 equals 0, so s squared is equal to half. So s, which remember is sine x, is equal to plus or minus root 3 over 2, or s is equal to plus or minus 1 over root 2. Now, if we look at a sine graph between 0 and pi, graph of y equals sine x between 0 and pi, maximum at pi by 2, then we can see that clearly everything is positive, so we cannot have these negative values here. So sine x is equal to root 3 over 2, or sine x is equal to 1 over root 3. Now we're going to need our special triangles. So we have half of an equilateral triangle with a side of 2, so half side 1 and the other side is root 3. The angles seem to have gone into very strange places. So we have an angle here pi by 6 and an angle here pi by 3, and the second special triangle we have an isosceles triangle of side 1, the square root of 2 is the hypotenuse, and that's pi by 4. So which angle has a sine of root 3 over 2. Root 3 over 2, that's opposite over hypotenuse, that must be pi by 3. So we have x equals pi by 3. Again, looking at our cast diagram, if the first angle here is pi by 3, the second angle here must also be pi take away pi by 3, which is pi take away pi by 3, which is 2 pi by 3. Similarly, which angle has a sine of 1 over root 2? Well, that would be pi by 4. So x equals pi by 4, or the second angle. Similarly here, pi take away pi by 4 is 3 pi by 4. And those are your answers.